Asphalt paving is every bit as important to local roads and streets as it is to state and interstate highways. And proper inspection of the work is just as critical. It's your job to ensure that the citizens of your community get the high-quality asphalt pavement they deserve. This videotape training has been developed as part of the Local Technical Assistance Program, LTAP. It is designed to give you, who are responsible for construction and maintenance of the local road system, the information you need to effectively inspect asphalt paving operations. In addition to the video, there's a checklist to remind you of the key inspection points. Now, because of our country's move to metric measurements, we're going to use metric units throughout this presentation and in the checklist. The video is in 3 parts, so after a few minutes of viewing, you can discuss what you've just seen and heard. All 3 parts are on this tape. Here in Part 1, we'll look at your responsibilities before paving begins: document review, coordination with the public, field review, equipment checks, traffic control, and weather requirements. Then, we'll look at inspecting the tack coat application. Part 2 covers the paving operation itself. And Part 3 shows some of the problems that can occur with mixed quality, laydown operations, and rolling. So let's get started. Document review. First, as with any project, review the contract documents. This includes your agency's bid specifications, including amendments, any special provisions, the appropriate sections of the construction manual, and the traffic control plan. Paving details can vary significantly from one job to the next, especially for traffic control. The traffic control plan identifies the types of signs and devices necessary, as well as their placement. So always study it carefully. And remember, no changes should be made to the traffic control plan unless the changes have been approved in writing by your agency. After reviewing all the project documents, find out what plans have been made to coordinate the paving operation with the utilities, businesses, and residents who will be affected. As necessary, utilities may have to be notified early so that arrangements can be made to adjust manhole elevations. Also, any planned crossroad utility cuts must of course be completed and patched before the new pavement is placed. Businesses should be contacted to arrange access times for employees if entrances and exits will be blocked by the paving operation. Private residents must be notified too. As the inspector, you should check out all such arrangements before paving begins. You should also take time to review the field conditions. The first 2 rules to remember are: always wear a safety vest when you're working near equipment or traffic, and always remember where you are. Even though a vest will make you clearly visible, a few steps in the wrong direction could be fatal. Some areas of the existing surface may need to be repaired before the road is paved. The locations and extents of these defects, such as potholes and areas needing pre-leveling, are typically marked on the pavement. See to it that this repair work is done properly. Along with pothole repair and pre-leveling, many projects specify milling. Milling is often used in urban areas so that the new pavement will match up with existing manholes and curbs. This procedure is also effective in eliminating wheel ruts. When milling is required, your first major concern is that the pavement is milled to the proper depth. Also, be sure that the milling equipment does not tear or rip the surface. In addition, make sure that the contractor takes appropriate measures to control dust and to maintain proper drainage from the pavement. Once the surface is properly prepared, your next preliminary responsibility is to check the paving equipment. First, get familiar with the equipment that will be used. The paving train consists of haul trucks, a paver, and 2 or more rollers. A distributor applies the tack coat to bond the pavement to the underlying surface. A power broom sweeps off the surface ahead of the tack application. Now let's take a closer look at each, beginning with haul trucks. There are 3 types: belly dump, rear dump, and conveyor. Regardless of the type of truck used, a major concern is fuel and oil leaks that can contaminate the mix. So spot check all trucks before paving begins and from time to time during paving to see that there are no leaks. When rear dump trucks are used, look around the hydraulic rams and connections too. Leaks this severe are unusual, but they do happen. If you find a leak, see that the contractor takes whatever measures are necessary to remove the spillage ahead of the paver. And of course, the equipment should be removed from the project and repaired. For safety, be sure that all truck backup alarms work properly. Another concern with haul trucks is the use of tarps to cover the mix. Tarps may be required to keep the mix hot or to keep out dust that would contaminate the load. Finally, contractors typically use a releasing agent to keep mix from sticking to truck beds. Be sure that it's an approved non-petroleum agent. Diesel fuel or other petroleum solvents must never be permitted as releasing agents. They dissolve the asphalt in the mix. To keep the mix from becoming contaminated, the releasing agent will have to be drained off completely before the mix is loaded. Although this is an inspection concern at the plant, you too should be on the lookout for contaminated loads at the job site and notify the plant if you see any. Okay, now let's look at the paver or laydown machine. There are many types, but all consist of a tractor and a screed. The tractor, of course, provides the power and includes a hopper where the mix is deposited. The screed's functions are to smooth and partially compact the mix. When belly dump trucks are used, a pickup machine is attached to the front of the tractor. Let's take a closer look at each component, beginning with the pickup machine. As you can see, it's pretty basic. The wings on each side of the machine are used to channel the mix toward the paddles, which in turn load the hopper. A plate is mounted below the paddles to ensure that all the mix is picked up. Rear dump and conveyor trucks load the paver directly. 2 push rollers mounted on the front of the hopper push the truck along as the truck loads the hopper. Inside the hopper, 2 flight chains carry the mix through the tractor. The flow control gates over each chain are adjusted to allow the right amount of mix to pass through. As the mix comes out of the back of the tractor, the auger distributes it evenly in front of the screed. On many pavers, paddles are mounted at the center of the auger to keep material flowing toward the edges. A slope shoe, like you see here, may be attached to the screed to bevel the outside edge of surface courses. And that brings us to the screed unit. The screed acts independently and is pulled by the tractor. It strikes off the mix and partially compacts and smooths it through its vibratory or tamping action. See that the surface of the screed is smooth. A warped screed, or a screed with worn edges, can rip the new surface or cause the pavement to be uneven. You should also check into the adjustment of the screed. All pavers are equipped with adjustment bolts for the leading and trailing edge of the screed. Some pavers are also equipped with indicators so you can easily see the adjustment settings. The leading edge of the screed should be set slightly higher than the trailing edge, by about 10 millimeters initially. This presses the material under the screed where it is struck off, partially compacted, and smoothed. Many screeds can also be extended and retracted to accommodate various paving widths. If such an extension is being used, make sure the auger is the same length as the extension. If the screed is manually controlled, there will be 2 screws that are used to control the depth of the mix being placed. These should be set at the beginning of the work and rarely adjusted during the operation. Another function of the screed unit is to regulate the grade and cross slope of the mix being placed. That's important. Maintaining the proper grade and cross slope are critical in getting a quality pavement. So many pavers are equipped with highly sensitive electronic devices for controlling both grade and cross slope. Some agencies require that the grade be controlled with a sensing device and a long ski. The ski provides a moving reference for the sensing device. The sensor is located in a small box with an arm extending below it. The arm rests on the ski and detects bumps or sags in the surface. Then, through electronics and hydraulics, the screed is automatically adjusted to provide a smooth surface. To get the best results, the sensing device should be mounted between 2 and 3.5 meters ahead of the screed. The cross slope is controlled by a sensing device mounted on the screed and connected to the control mounted on the tractor. The cross slope needed for the particular job is preset so that the sensor can continuously adjust the screed to maintain the proper cross slope. There's a lot more involved with grade and cross slope control, but we'll look at both in more detail when we get to the paving operation. Now let's look at the rollers. There are many types, but all can be classified as steel-wheeled or pneumatic-tired. For leveling courses, a pneumatic-tired roller works best because the kneading action of the tires works the mix into the depressions. Steel wheels, on the other hand, tend to bridge the low spots and not compact the mix as well. All other courses can be rolled with steel-wheeled rollers or a combination of steel-wheeled and pneumatic-tired. The main point with rollers is that the compaction requirements have to be met. The contractor needs enough rollers of the proper weight, in good condition, and operated properly to achieve compaction without damage to the mat. So let's take a closer look at the rollers, starting with steel-wheeled. The 2 most common types are 2-wheel and 2-wheel vibratory, although you may see 3-wheel rollers as well. The vibratory rollers can be operated either with or without vibration. The vibratory mode is used in the beginning of the rolling operation because it provides the most compaction. The static mode, that is without vibration, allows the same roller to smooth out the pavement. The first thing to check on all steel-wheeled rollers is the drums. If they're not smooth, there's just no hope for a smooth pavement. You should also check the scrapers and mats. They remove mix that sometimes sticks to the drums. If it's not scraped off, this mix can mar the pavement surface. The drums also have to be kept moist, so make sure all the sprinkler nozzles are working. And finally, look under the roller. Make sure there are no oil or fuel leaks. Either kind of leakage will contaminate the mix. And that covers steel-wheeled rollers. Now let's look at pneumatic tired rollers. Tire pressure greatly affects the performance of these rollers. All tires must be inflated to the same pressure within the tolerance suggested in the checklist. In addition, these rollers should have a working weight capacity of at least 115 kilograms per 6 centimeters width of tire tread. So measure the width of the tires and divide the number of centimeters into the total weight of the roller. Your checklist covers these calculations in detail. Now let's have a look at the hand tools required. Only lutes and shovels should be used. Lutes are used primarily in constructing longitudinal and transverse joints. The important thing is that it's lutes, not rakes. Rakes are shaped differently and cause segregation of the mix. They just don't do the job properly. Just one more point about hand tools. Most contractors store them in containers filled with diesel fuel. That's perfectly acceptable, as long as the fuel isn't spilled on the mat. While the hand tools are in use, however, they should be cleaned with a putty knife, not with the diesel fuel. And they shouldn't be cleaned by scraping them off on any part of the laydown machine either. And those are the equipment checks. Now let's look at traffic control in a little more detail. As you heard in the beginning of the program, a traffic control plan should identify the types of signs and devices to be used and where they should be placed. So you should always inspect them as they're set up to be sure they comply with the plan. Now, although the exact signs and devices and their locations will change from project to project, there are a number of principles that apply to all traffic control zones. First, the traffic control setup should comply with the Manual on Uniform Traffic Control Devices. Second, when traffic has to be alternated through the work area, make sure the flaggers work together to avoid holding traffic too long. Third, report any unsafe conditions to your supervisor as soon as possible. And fourth, make sure all signs are removed or covered when they no longer apply. Motorists learn to ignore signs when they don't see any roadwork. Your final preliminary concern is the weather. Temperature, precipitation, and wind are factors in determining whether or not to pave. Most agencies require a brief documentation of daily weather conditions on paving projects. To begin with, the mix should not be placed when temperatures are too low. Check the specs. Many agencies base their limitations on air temperature, others on surface temperature, and some use both. Cold temperatures, of course, will cool the mix, making it difficult to get adequate compaction. In addition, the fresh mat may not adhere to a cold surface, so always check the actual temperature with a reliable thermometer. You should also be aware that many agencies have calendar date restrictions, such as no paving allowed after October 15th, or before April 15th. These restrictions are provided to help prevent the problems associated with low temperatures. Again, be sure to check your agency's specs. Precipitation is a concern. Asphalt paving should not begin when rain is about to fall or too soon after it's fallen, while the surface is still wet. Occasional sprinkles or passing showers have to be dealt with according to their volume and duration, from working right on through the minor ones to temporarily halting for the more serious ones. Winds by themselves may not be cause to avoid paving, but they sure can mess up the tack application and cool down the mix real fast. So use good judgment. If weather conditions prevent good work, take the necessary action. Now we'll look at the last item on the list, the tack coat. The purpose of the tack coat is to bond the new pavement to the existing pavement. So first, it's very important to thoroughly clean the surface. And then cover it uniformly with the right amount of tack. But there is a lot to inspect. To begin, check the contract documents to see what type of tack material is to be used. Most agencies require emulsions, but some use asphalt cement or cutback asphalt. As inspector, you may have to sample the tack. If so, be sure to follow your agency's procedures for collecting, documenting, and submitting the samples properly. Next, find the application rate for the tack coat in the contract documents. Many agencies will allow you to make small adjustments in the application rate depending on the condition of the surface. Basically, you'll always use more tack on old and milled surfaces than you will between new courses. Then, record the number of liters in the distributor so that later you can calculate the application rate. You'll also need this information for payment purposes. Before the material is applied, see that the surface is both clean and dry. Otherwise, the tack won't bond the new pavement to the existing surface. Then, verify that the tack material has been heated to the proper temperature. The contract documents typically give a temperature range. Also be sure that the distributor's pump pressure is correct and constant according to the manufacturer. Next, look at the spray bar, starting with the nozzles. They all have to be clean and angled in the same direction to get the proper coverage. And check the height of the spray bar. The proper bar height, nozzle angles, and application pressure determine the quality of the tack spray pattern. Generally, you want a double or triple lap coverage. This is a good tack application, smooth, even, and uniform. Look over the application closely. If you see any bare spots or lightly covered areas, stop the distributor and get the problem corrected. It could be just one plugged or misaligned nozzle, so make the necessary adjustments. After the material has been applied, be sure to record the number of liters remaining so you can calculate the application rate. To do this, you divide the number of liters of tack applied by the area covered. The length of application times the width in meters. The rate is so many liters per square meter. Here are some more points about the tack coat. Don't apply more tack than can be covered the same day. Also, be sure traffic and dirt are kept off the tack coat. Both will hamper the bond. When emulsions are used, make sure the material breaks, loses its water content, before the mix is placed on the surface. You know this has happened when the tack turns from brown to black and becomes sticky or tacky. When asphalt cement is used, the mix can be placed immediately. However, when a cutback asphalt is used, it must first cure. That is, the solvents must evaporate. You can check the application with your finger. Before a cutback cures, your finger will pick up an oily film. After it cures, there's no oily film, and the surface is tacky or sticky. With that, we've covered your preliminary inspection responsibilities and the tack coat application. In Part 2, we'll look at the paving operation itself. High-quality asphalt pavements don't just happen. They're a result of thorough preparation, good communication, and most of all, the inspector's attention to the details. In this second part of asphalt paving inspection, we'll look at mix delivery, placement, compaction, and transverse joint construction. We'll start with delivery of the mix. The first thing to do is collect the delivery ticket from each haul truck. The ticket tells you the type of mix, the weight of the material, the time the truck left the plant, and in some cases the project number. Your job is to record the time the mix was received and where it was placed on the job. You'll need this information later to calculate the amount of material placed. You should also compare the gross vehicle weight with the weight shown on the delivery ticket to be sure that the trucks are not overloaded. Some agencies require you to reject overloaded trucks. Check the contract documents to be sure. You'll remember from Part 1 of this course that there are two ways to deposit the mix at the project. The conventional method, where the haul trucks load the paver directly, and the windrow method, where the trucks dump the mix in a windrow and a pickup machine feeds the paver. In both cases, it's important that you inspect the mix as it arrives. Your first concern is with temperature. Too high a temperature can damage the asphalt binder in the mix. But if the mix is too cold, as you already know, the rollers won't be able to compact the mix adequately. The mix should be about 115 degrees Celsius when it's delivered, because best compaction is obtained when the rolling is completed before the mat temperature drops below 90 degrees Celsius. Check your agency's specs for the minimum mix temperature requirements in your area. Then, record the mix temperature. Inform your supervisor and the contractor if you think it's too low or too high. You should also visually inspect the mix. You can tell a lot by its appearance. Some problems will require that adjustments be made in the batching or hauling of the mix. Some problems may be serious enough to outright reject the whole truckload. Later in Part 3, we'll look at some examples of defective mix to help you recognize such problems. In any case, tell the plant inspector, the contractor, and your supervisor immediately if something doesn't look right. Along with your visual inspection, be sure to note the stationing from time to time so you can spot check how much material is being placed throughout the day. You do this by first totaling the weight of mix placed on the road as accumulated from the delivery tickets. Next, you determine the length of roadway paved from the stationing and multiply it by the width paved to get the total area covered. Then, divide the amount of mix placed by the area paved to get the yield. Your checklist has several sample calculations. A couple more rules about delivery of the mix. The first rule is the contractor should have enough haul trucks to maintain a constant supply of material to the paver. That way the paver moves forward continuously at the same speed. In addition, a constant supply of material means that the mix will be placed and compacted at a constant temperature, and that helps produce a good mat. Rule number 2 is that rule number 1 is nearly impossible on high-volume two-lane roads. In these situations, even the best efforts to maintain a constant supply of mix to the paver may be frustrated by haul trucks stuck in traffic. The best solution here is to stop the paver quickly when stopping is necessary, and then to reach paving speed quickly when paving resumes. This helps to avoid depth changes and mat roughness as a result of variable paving speeds. Now let's take a look at mix placement, beginning with the conventional method. First, the haul truck should stop about a half meter from the paver so that the paver can move forward to contact the truck tires with its rollers. See that this contact is made smoothly and evenly. The haul truck begins to load the paver as the paver pushes the truck. Make sure the truck and the paver work closely together to avoid dumping mix outside the hopper. If you see material spilled ahead of the paver, make sure it's shoveled up so the tractor won't run over it. Another concern during placement is mix sticking to the sides of the hopper. What we want to avoid is cold, hardened mix mingling with good mix. Some people insist that the wing should be raised and lowered after every truckload. Others maintain that the wing should never be moved. Both arguments are valid, and either practice should be allowed, provided that only hot mix is used in the pavement. So if the wings are raised, there must always be ample mix on the conveyors for the wing material to mix with. When the windrow method is used, one of your main concerns is that all the mix is picked up. So see that the wings and the plate rest flat on the surface. If any material isn't picked up, have the contractor shovel it away from the wheels so it won't be run over by the pickup machine or the paver. From here on, your inspection concerns are the same for both methods. Check the overall quality of the mat. It should be smooth, uniform, and free of blemishes. If it's not, something is wrong with the paver or the mix. And look closely again for segregation. If the texture of the mat isn't uniform, the mix has segregated. Inform your supervisor and the contractor right away. Again, we'll look at some examples of mat problems in Part 3. Keep in mind that very few operations will run perfectly, so the important thing is for you to communicate. The depth of placement is also important. The contractor should make several loose depth checks using a depth gauge. A general rule of thumb is that the mix will compact about 20% in depth. So as an example, if the course being placed is supposed to be 60 millimeters thick, the loose depth should be about 75 millimeters. If changes in depth are necessary, the contractor should make the adjustment gradually. Both you and the contractor should then let the paver advance about 10 meters before rechecking the depth and making further adjustments. Where a shoulder is paved along with the adjacent travel lane, check the shoulder slope of the new mat. The typical section sheets will identify the proper slope, normally 5 to 1 or flatter. Now, before an adjacent lane can be placed, both the surface and the longitudinal joint have to be tacked. Then, after tacking, the second lane can be paved. The paver is lined up so that there's a slight overlap into the first lane. After the paver goes by, the joint should be ready for rolling. In some cases, however, a small amount of handwork may be necessary, using a lute to bump the overlapped mix back into the joint. When handwork is required, it should be minimal. Never allow anything like this. Now the joint can be rolled. We'll cover compaction in more detail later, but for now, just remember that longitudinal joints should always be rolled before any other section of the mat. Now let's look at grade and cross slope control. You'll remember from part 1 that the pavement grade is controlled by a sensing device with a long ski. You should watch the ski as the paver moves along. Make sure it pulls straight while remaining parallel to the longitudinal joint. If these conditions are met, the rest is automatic, for grade control anyway. As for cross slope control, see that it's properly set and that the contractor checks it from time to time with a slope board. Be on the lookout for excessive cross slope. That's just a waste of material. Now let's look at compaction. Compaction makes the pavement dense, so it will maintain its shape and have the required strength for traffic loads. Different types of rollers may be used and different rolling patterns may be followed from job to job, but all rolling must achieve the desired density, smoothness, and surface texture. Generally, there are 3 phases to rolling: breakdown, intermediate, and final or finish. Again, the equipment may vary, but a typical arrangement is for a steel-wheeled vibratory roller to perform the breakdown rolling, achieving much of the density required. Followed by a pneumatic tired roller to do the intermediate rolling. And then a static or non-vibratory steel-wheeled roller to provide the final or finish rolling. This last phase should remove all roller marks. On jobs where 3 or more units are not available, the rollers used should be operated to obtain full coverage and leave the mat with the required density and surface quality. Now here are some tips when you inspect the rolling. First, watch each roller as it reverses directions. It should come to a stop gradually and then reverse smoothly. And that one brief stop needed to reverse direction is the only stop permitted on the new pavement. The roller should proceed in as straight a line as possible. When turning is required, it should be done smoothly and gradually. The speed of rolling is also important. Rolling too fast can result in damage to the mat, so see that the rollers work at about walking speed. On super elevations, rolling should start on the low side. Each pass overlaps the previous pass 15 to 30 centimeters. The rolling progresses toward the high side to keep the mix from shifting to the low side. Remember though, longitudinal joints are always rolled first, regardless of their location. The density of the pavement may have to be checked too. Some agencies use nuclear density gauges similar to this one and require all gauge operators to be formally trained and in some cases certified. You should know that while it's important to roll the mat until it's dense enough, it's also possible to over-roll the mat. Too many roller passes may actually begin to reduce the density. After the pavement has been compacted and is cooled sufficiently, temporary pavement markings should be placed along the center line if the pavement will be open to traffic. These markings must be placed for the full length of the area paved by the end of each paving day. Now let's look at transverse joint construction. This involves making cold construction joints across the pavement perpendicular to the roadway center line. The joints are made when the contractor stops work at the end of the day, when the paving operation is delayed, or when bad weather is imminent. The first step in constructing a transverse joint is to cut away and remove the mix to a point where the mat has the required depth and slope. Since this is the point where paving will begin again, you need to be sure that the two mats will match up when paving resumes. Now, whenever the road is to carry traffic in the meantime, such as overnight, a temporary ramp must be constructed to provide a smooth, safe transition between the new pavement and the old surface. Sheets of paper are typically used in constructing these ramps, separating the mix that will form the ramp from the existing surface and the vertical face of the joint. Enough widths of paper must be placed to hold a ramp of proper taper, usually 20:1. Such a taper length won't jolt motorists as they drive over the joint. Mix is then placed on the paper, up against the joint face and extending to the full taper length. The joint and the ramp must be compacted the same as the rest of the mat. Rolling across the joint and down the ramp ensures that the end of the full depth portion gets properly compacted. Before paving can resume at the joint, the mix forming the ramp must be removed and properly disposed of. Then, be sure that the surrounding pavement is clean and the face of the joint is vertical. The face of the joint and the area where the ramp was made now have to be tacked. The primary concern when paving resumes is the transition between the previously placed mat and the new mat. So the crew typically places small strips of wood under the screed to make up for the difference between compacted depth and loose depth. After the paver goes by, see that any excess material is removed. Now the joint can be compacted. In the process, checks should be made with a straight edge to ensure that the transition is smooth. You should observe this check and have any high or low spots corrected. And those are the inspection points for transverse joint construction, which brings us to the end of this part of the videotape. Communicating with the plant, discussing operations with the contractor, and keeping your supervisor well informed are all part of good inspection procedures. This communication, along with the use of the inspection procedures and ideas we've discussed, will result in a well-constructed and acceptable project. In the third and final part of this videotape, you will see examples of problems that can and do occur with mix quality, laydown operations, and rolling.
Did you ever have one of those days, you know, a Murphy's Law type of day where everything that could go wrong does go wrong? Well, in this third part of asphalt paving inspection, it will sure seem like one of those days. We'll have all kinds of problems with mixed design, paving, and compaction. But don't blame it on the crew. You know, usually it seems like every time we take out a camera to videotape an operation, a good operation mind you, something goes wrong. It's not planned, it's not even typical. It just seems like the camera is a curse. To make matters worse, this poor paving crew had 2 cameras on them. Well, actually, this is one of the best crews we've seen. They were so good, we had to ask them to be bad, to do things wrong on purpose, so we could show you what to look for. In doing so, we may talk about the causes of problems and show them being repaired. However, that's not the real purpose here. Identification is. So be aware that there may be other causes of problems and possible solutions besides those listed here. With that in mind, let's get started with the mix design. You'll remember from Part 2, you should always inspect the mix as it's delivered. There are several mix defects that can occur at the plant, especially a plant as schizophrenic as we ask this one to be. Blue smoke indicates that the mix is too hot, way too hot. If a haul truck delivers mix to the job that's still smoking blue, just imagine how hot it was at the plant. Check the temperature immediately and reject it if it's out of spec. Asphalt this hot is probably burned, so its chemical properties are altered, meaning its binding ability is lost. On the other hand, if the mix is too cold, the air or surface temperatures are too low, or the haul is too long, the results aren't too pretty. Lumps in the mix are a good sign that the mix is too cold. Lumps can also be caused by improper mixing. In either case, the lumps themselves present a problem. They aren't shaped by the screed, and they can't be rolled out. So they remain separate from the surrounding mix, causing weak spots in the mat. Try to catch them before they get to the mat. Otherwise, they must be dug out and replaced by hand. Another clue that the mix might be too cold is a stiff appearance. This can also be evidence, though, that there's not enough asphalt in the mix, especially if the mix looks dull. No, I don't mean boring, I mean lacking the normal shininess of fresh mix. A stiff, dull mix is a sure bet you'll have binding and compaction problems. Now, quite the opposite. Too much asphalt. Now, this may be as obvious as asphalt soup, a few aggregate floating in a pool of oil. Usually, though, you can tell by the flow of the mix. If it's more fluid than normal, chances are good the asphalt content is too high. This can cause compaction problems and bleeding on the surface. Segregation is also a common mix defect and can be caused by problems anywhere from building stockpiles at the plant to loading the hopper. Here, it's caused during truck loading at the plant. The larger aggregate rolled to the bottom of the cone-shaped pile. Pockets of fines and pockets of coarse aggregate are easy to spot. Unfortunately, it's not easy to do anything about them if they're already compacted in the mat. Reject a segregated load before it's placed. Otherwise, without the necessary interlocking of different-sized aggregates, the surface will soon begin raveling. You might think that excessive steam is also an indication that the mix is too hot. Actually, the temperature is okay. It's just there's too much water in the mix, which is usually caused by too much water in the aggregate and/or a dryer problem. This excess water can weaken the bond between aggregates and the asphalt. Another thing to look for in the mix is debris, or perhaps an oversized piece of aggregate. Here, a large rock got caught under the screed, causing this long gouge in the surface. Improper screed extension mounts, or an unheated screed at the beginning of the day, can cause similar streaking and other mat problems. You never know what might get into the mix, or what might get thrown in the hopper with it. You may be aware that some parts of the country use recycled asphalt material. As of yet, though, no one recommends paving with recycled aluminum. And those are some common mix defects. Again, the key is to spot them early. Ideally at the plant, but if not then, at least before they reach the screed. But even the best mix can't overcome faulty paving practices. Let's start with haul trucks. Can there ever be too many? Sure. And if they wait too long, the mix will get too cold. However, that's so rare, it's hardly worth mentioning. A more common problem, of course, is not enough trucks, especially when you have a long haul distance. True, long pauses provide great breaks for the paving crew. Unfortunately, the weight of the screed resting on the mix will create an indentation in the mat when paving resumes. This can put a lot of pressure on drivers to speed things up, which often leads to another consequence: trucks bumping the paver. The result, besides an upset whiplash victim, is that the truck knocks the screed back into the mat, creating a crease. A problem that's hard to fix, but simple to avoid with a little effort on the driver's part. Something that might take a little more skill for the truck driver is working on hills. Remember, in most cases, the truck backs up to within a meter or so of the paver and stops. The paver moves ahead and pushes the truck while the truck loads the hopper. That's simple enough on flat ground. But when going down a hill, the truck driver needs to apply the brakes, or the truck will pull ahead of the paver and spill the mix. So the driver may hold the brakes too hard, which will cause the paver to spin at first because of built-up momentum. Then, when the driver releases the brakes, the paver will frog or suddenly lurch forward, leaving a dip in the mat. If you're working on hilly terrain, consider using a hitch, or a device like this, which is inserted in the truck's wheel wells to hold the truck in place. Now, sometimes mix may spill ahead of the paver when the truck is finished loading. Some crews shovel this mix to the middle. Others remove it. What no one wants, though, is a pile of mix that the paver's wheels or tracks will run over. Even though most screeds respond to the sensing device, they are still attached to the paver. If the paver suddenly rises, it brings the screed with it, before the screed can adjust, leaving a corresponding bump in the pavement. Here, for our dramatization, our pile of spilled mix created a virtual speed bump. While we're behind the paver, let me introduce Windmill Johnny. It's easy to see how he got his name. He's constantly whirling and twirling the mat depth controls. Depending on the machine and the intervals between adjustments, he's either accomplishing nothing, or these abrupt changes will show up in the mat. Rumor has it that the roller operators on Johnny's job often get seasick. But those roller operators aren't without blame themselves. Let's leave the paving operation and look at some compaction problems. Some people call this hot mix. Some people call it hot asphalt. You can call it hot for short because it sure is, especially in the middle of summer. A nice cool drink is not just a luxury, it's a requirement. But never park the roller on the fresh mat, especially right behind the paver. The weight of the roller depresses the mat, causing a bird bath. And fortunately for the crows, and unfortunately for you, it can't be rolled out. But the fact that you shouldn't park on the mat doesn't mean you can enter and exit the mat at will. You can see what happens going from the traveled surface to the fresh mat. There's no way to properly repair this. We asked this operator to do it for the video, and his supervisor still almost fired him. Rolling these edges can be tricky. Because of the lack of lateral confinement, the mix tends to shift or roll out under the roller. Sometimes a minimal amount is unavoidable. But if there's excessive rollout, the mat temperature may still be too high, or there may be some type of mix defect. Rolling while the mat is still tender will cause pushing or shoving anywhere in the mat, not just the edges. The same problem can also be caused by sudden roller stops and reverses. For steel wheel rollers anyway. For pneumatic-tired rollers, sudden stops and quick gear changes will scuff the mat. And if the mix is cooled too much, almost any change in roller direction may leave marks on the mat. And for either type of roller, the scrapers and water nozzles must be working properly. Otherwise, they'll pick up mix, a surface defect in itself, which ends up leaving impressions each time the clod of stuck mix impacts the surface. To add insult to injury, you'll end up trying to scrape hardened mix off the roller. A difficult task. And don't even think about using diesel fuel to make it easier. Remember, if it dissolves the mix on the roller, it will dissolve the mix in the mat. And that was the last problem with compaction we'll cover, which certainly makes the paving crew a lot happier that they can return to normal. It also means we've come to the end of this program on asphalt paving problems. You'll notice we didn't spend much time discussing how to fix these problems. That's because the key to proper paving and inspection is learning how to recognize potential problems and prevent them. Hopefully, this program will help you do that on your projects, not just help you spot those major goof-ups by that crew from the next county over.